Okay. Before we jump into 6.2, we've got some warm-ups. If P is a supplement to R and the measure of angle P is 164, find the measure of angle R. What do we know about supplementary angles? They add up to 180. So the measure of angle R would have to be 16 degrees. 16 degrees. So 180 minus 164. That word supplement or supplementary is going to be making a comeback. Find the value of x. So in this diagram, what do we know about those two angles? Good. They make a straight line. That makes them a linear pair. Linear pairs are supplementary. So these two angles together would add up to 180. So 2x plus 117 plus x is equal to 180. Combine like terms, what do we get? Okay, I'm going to do that 2 steps, but yes, so we combine like terms, we get 3x plus 117 equals 180. Then when we subtract 117 from both sides, 3x equals 63. Our last step is to divide. And what do we get for x? 21. Questions about 1 or 2? Okay, on number 3, 4, and 4, we're finding the measure of angle A. So we know all the angles inside of a quadrilateral add up to 360. So we would take 360 minus 100 minus 85 minus 95. What would we get? What'd we get? 80? We all agree with 80 degrees? Okay, on number 4, same thing, except we have to remember that these little boxes mean how many degrees? 90. So what do we get for the measure of angle A? 108 degrees. Last one is similar, but we are finding the value of x. So we know if we add up all 4 angles, it should add up to 360. So we would have x plus x plus x plus 165 equals, ran out of room, 360. So when we combine like terms, how many x's do we have? 3x plus 165 equals 360. Subtract, we get 3x equals 195. And then we would divide by 3. What do we get for x? 65. Okay, and then x doesn't necessarily need a degree symbol. The degree symbols were by the x's. Questions about our warm-ups? Bella?
On our quiz, is it okay if we don't show the label as combining like terms?
Yeah, that's fine. If you were to write 3x plus 165 right away, that's fine. Other questions? Okay. We'll move along. I think this is one of those ones that doesn't have the objective written, so I'll add an objective up at the top for us. Our objective is simply to use properties of parallelograms? Thank you. So we will use properties of parallelograms. They will help us find angle measures and side lengths. Yesterday when we were talking about naming polygons and we came to a four-sided polygon, some people were saying things like square or rectangle, which are types of four-sided polygons. I told you that if all we knew about it was that it had four sides, it had to be called a quadrilateral. So today we're talking about the next level down of being a little more specific. Some quadrilaterals are parallelograms. The defining feature of it would be that both pairs of opposite sides are parallel to each other. So one way you'll know that you have a parallelogram is if they give you the figure and they mark the sides as being parallel. How do we know when sides are marked as being parallel? Okay, they got the little triangles. We'll get there. So the little triangles tell me that those sides are parallel to each other. So that would mean the other side would have to have, the other pair of sides would have to have two triangles. The symbol for a parallelogram is a little parallelogram. So it would be this figure without the arrows on it, just a little one. You just make a little parallelogram. Oh, mine doesn't look quite good enough. A little parallelogram is the symbol that we use. It's kind of like a slanted rectangle. Make it more or less slanted. It's a little tricky for me to draw them on here because I can't judge my spacing as well. That's a little bit closer. Any questions about that before we talk about some of their properties from the theorems? For sure. Done with the objective and all? Okay. So if we know that we have a parallelogram, then we know several things about it. I'll use some of these diagrams down at the bottom to help me label it. So if in the margins you want to draw parallelograms that show these features, you can. Give you a second to write before we talk about them. All right, first theorem or property that we're going to talk about is pretty easy. Opposite sides are congruent. So by the definition, opposite sides are parallel. They are also going to end up being congruent. So I could give them tick marks to show that opposite sides are congruent. This does not mean that all four of them are congruent, just that we have pairs of congruent sides. Second one I'll put in the same diagram. Opposite angles are congruent. Again, ones that are across from each other in the parallelogram are congruent, but that does not mean that all of them are the same. Have pairs that are the same. Number 3 gets a little bit trickier. Consecutive angles are supplementary. Consecutive angles mean that they come one right after another. So if I were to label this as A, B, C, D, give me 2 consecutive angles there. A and B would be consecutive angles. So the measure of angle A plus the measure of angle B has to add up to, if it's supplementary, 180. So the measure of angle A plus the measure of angle B would have to add up to 180. And we could keep making more of those statements the whole way around. The measure of angle B plus the measure of angle C would also have to be 180. If there are 2 angles that are right next to each other in a parallelogram, then they have to add up to 180. Okay, so you could make as many of them as you wanted. There would be 1, 2, 3, 4 statements we could make. I've only written 2 of them. Questions, concerns about that property? Okay. The last one, I'll go ahead and use that same diagram since the logo cuts into my last parallelogram. The diagonals bisect each other. How many diagonals are there going to be inside of a parallelogram? How many diagonals are going to be inside of a parallelogram? 2. Okay, remember a diagonal connects a vertex with a non-adjacent vertex. So if I were to start at A, my only diagonal could go to C. So there's one of them. Okay, that's the only diagonal that can come from C goes to A. If I'm coming out of B, where does my only diagonal go? To D, and vice versa. So there are only 2 possible diagonals inside of a parallelogram. The diagonals bisect each other. What does the word bisect mean? Splits it in half. Okay, so it's not just that they touch each other or they cross each other. It's very specific. They intersect so that they cut each other in half. So if I were to label this middle point here as E, I could say that AE is congruent to what? CE. I could also say that BE is congruent to DE. And you could go through and put some tick marks in there. However, AE is not necessarily congruent to BE. Okay, they're not part of the same diagonal. So I could put 1 tick mark on each of those and 2 on each of these, but it does not mean that they're all the same. Okay, with parallelograms, we end up with a lot of pairs of congruent parts. Thank you. Questions about any of these properties? Need more time with them. Okay, the nice part about this is that it makes the examples pretty easy because pretty much you're either looking for things to be congruent to each other or you're looking for angles to add up to 180. Those are really the only options that we have. So I'll give you a second to jot down these parallelograms. Probably take you just as much time to copy them down as it will to answer them. Your pictures don't have to be perfect. These are not marked with the little triangles, but the directions told us that it's a parallelogram. So as long as the directions say it's true, we need to believe it. All right, on 1A, what is the measure of MN? 15. Okay, the opposite sides are congruent, so that one has to be 15, and that means KN is 6. Again, opposite sides congruent. So on letter B, MN is 8 and KN is 12. Easy enough? Questions, concerns, need more time? We'll keep it moving. Oh, I think I copied these into the next one. I did. Couple more parallelograms. This time we're going to find missing angle measures. When it says this, it means find all missing angle measures. All right, when you're finding missing angle measures, there will usually be one angle that's easier than the others. On 2A, should label that with an A, 2A, which angle is easiest? T, why? It's good. It's opposite the angle that we know, and opposite angles are congruent. So angle T is also 75 degrees. How are we going to find S or V? Oh, so that brings up a good point. There are technically two ways we could find it. Okay, the property we talked about today is that consecutive angles are what? Supplementary, which means they add up to 180. So we could take 180 minus 75, and that would give us angle S. What would that be? 105 degrees. But we know that S and V have to be congruent, so it's also 105 degrees. Technically, you could use the property of quadrilaterals that they have to add up to 360. If you were to take 360 minus 75 and then divide it by 2 to split it between those, that would also give you 105. I think it's easier to use your supplementary angles, personally. It's fewer steps. All right, on letter B, which angle is easiest right away? V, because it's opposite angle S, so it has to measure 130 degrees. The other angles, T and W, would have to measure 50 degrees to be supplementary to the 130s. A problem like that doesn't really have any algebraic expressions involved, I'm fine with you just filling in the answers. Okay. Questions, concerns, need more time? All right, we have two more parallelograms. All right, these ones have diagonals drawn in, and we are asked to find JN for both of them. Now, it's not necessarily hard on either one, but I think A is particularly easy. What is the length of JN going to be? 3. Are we all okay with 3? Okay, if these are diagonals, they are bisecting each other. So JN and NL would have to be congruent. Does that mean that MN is also 3? No, MN would be congruent to what? KN. But we don't know either of those. So we cannot assume anything about their measures. We only were given that 3. Questions about, bless you, 3A? All right, on 3B, does anybody think they know JN? Kylie? 8, very good. If we know that these have to be the same and that when they were put together it was 16, we just take half of that to get 8. Does that mean that MK is 16? No, we still don't know anything about the other diagonal except for that MN and KN would be the same. Questions about 6.2? Okay.